Yeah, hi friends. Welcome to the new series Advanced Calculus. Today we are going to start with a session. The session will be talking about the set notation. So today we are discussing about what exactly the advanced theory of the calculus. But before starting with the advanced one, we'll just discuss about few basic terms and the things we are going to use. So we are discussing about set. So let's start with the set. So let me just take a marker over here. So let we have we'll assume we have a is a set. So how we will represent a set? So I am saying we have a set A that having the values 1 2 3 4 5 up to the n. So this is a set that having the objects or elements or value it contains from 1 to the n. So the next one, this one is the simple annotations where we are denoting the elements. So there is one more criteria to representation of the set where we are defining the criteria. So defining the criteria means that let me assume I have another set B. This B set I am just based on the criteria. So the criteria is like x, the value of x. So uh, this x is less than equal to, so what I am trying to say, this x is less than equal to n. So this here we are specifying the criteria. So this set is known as the criteria set. So based on the this one is where we are representing the values in the or object in the set. Here we are representing the criteria. So there is one more representation that but normally we are not saying it's a set, but let me just tell you, sometime the people say that known as the interval notation. So what exactly the interval notation is? So interval notation in this case is where we are representing and saying so this x is starting from some one value and it is up to the value of n. So this is the interval. So the interval, the starting interval is n and ending interval is this. This starting interval is 1 and this is the n is the ending interval. So we'll say this one is an interval interval representation, we can say, or interval notation we can say. Okay, so now we'll just move to the next one. So where we have the operations in the sets. So the first operation that we perform in the set is the union operation. So how we will present is this A union of B. So the A union of B, how we present is x, the value of x belongs to A, or it can belongs to B also. So now the question arises that if some values, so if I am like here we have 1 2 3 up to n, here also 1 2 3, so both have the 1 2 3. So or means if any one of the condition is true, it will take that one. So that one is the or. So we are not duplicating the values in it. Okay, the next one is the all the values of A and the B, and no duplicate value will be come in this. Okay, now we have this A intersection B. So intersection B means what are the common values we have, we will take that one. So how we will do that? X belongs to A and operation, and X belongs to B. So if the value satisfy both the sets, then it will become. So if I am saying if I have this set A having the value 1 2 5, having the set B the values is 2 and 9. So when we perform the operation here A intersection B, so A intersection B, which value is the common? So we will check the one is one value will exist in the set A, but it not exist in the B. So this we will not take 1. So then we'll go for the 2. If the 2 exist in both of the set, then we'll take 2. So the intersection of this set will be the only the set 2. So we'll come having the 2 value only. So now we will move to the next one. So uh, where we have the minus. So how we will represent B minus A. So how we will represent it in the set theory. So we'll write here x belongs to B, x belongs to B, and x not belongs to A. So that is the minus. Same way we can represent the A minus B also. We can represent A minus B, where A minus B, what we are doing here, x belongs to A and x not belongs to B. So that is the a minus b. Okay, so this is about the basics of this set, how what exactly the set is and what are the operations we perform. Now we'll come into the some notation part. So we'll come into the next thing. So in the notation one, what exactly the meaning? So we have some symbols that defines that this is a set having the natural numbers. So how we will first I'm talking about natural numbers. So how we represent this? So natural number, there is a set will represent this one. So this is a set. This set itself says that so this is the in the set theory. So whenever we write like this, what it means, it is a natural number. So natural number, we have 1 2 3 up to the n, we have these natural numbers. Okay, so same way we have the natural numbers, we have the integer numbers. So we'll write here integer numbers. Integer set, how we'll represent the integer set? So integer set will be represented like this. So this is the integer set. So what it means, the integer set will have the uh, plus n to, up to the minus n to the plus n. So this one is the integer, it can have the positive and the negative, both the values. So the objective is how we'll write this one. So this is written like this one. So this is the integer set. Okay, so now we have another notation that come into the picture, that is the rational number. That is rational number. So how we represent the rational numbers? So rational number are represented like this one. So this is the symbol that we represent the rational numbers. So how it comes? So we have a divided by b. So what exactly the a stands for, where a comma b belongs to, so this belongs to we have the natural numbers, or we can say the negative. So I'm just right now I'm just representing it's an integer. So this will be an integer. Okay, where b and b not equal to 0. So this is in set, this is the symbol, this signify itself as a rational number. So now we'll come into the another symbol, that is the complex number, that will define the complex number. So how will define the complex number? The complex number, the symbol, the complex number is defining like this, d. So the complex number, how it is represented? So we have one real part, another one is an imaginary part. So here we have a and b belongs to this, a and b, this belongs to real number. So how we represent the real number? This r is represented as a real number. So I'll forget about to tell you about this real number. So this one is the real number, the form that we are representing is, so we are writing this real number as this. So this real number, it means minus infinity to plus infinity, we have plus infinity, these are the real numbers. So now this is the these are the some symbols that we are going to use in our quantum theory or quantum computation, where these symbols will be represented. At that time we have, if we don't know about this symbol, so it will be difficult to understand what exactly what the statement want to be say. So we have to be little bit aware about these symbols, what these symbols represents. So now we will come into the another part of some quantifiers. So what exactly that one? So we have one more symbols that is normally used. So this is the symbol states that this symbol is for all. This symbol is for all. So now another is, if we have represented E in reverse order like this one, so what is the meaning of this symbol? So this symbol means there exist. So now let's now discuss about this one. So what exactly the meaning it? So if we have written like this, for all x belongs to the real number. So it what it means? It means for all, this is for all values of x belongs to real number. So that is the main this statement that we have written over here. This represents this one. Same way we can have we can specify here as this one. So I am just writing here this set of x belongs to I am saying this is another set of the real numbers. Okay, and we can have also set we have y, this does not belongs to the real number. Okay, so basically these are the few notations that we are going to discuss about in the quantum, and basically it's also used in the machine learning as well when we are talking about. So we have little bit idea about these symbols and all. Okay, so in the next section we'll discuss about the next topic in advanced calculus. Thank you.